next and last speaker before lunch is Terry McNabb. He's a graduate of Michigan State University with a degree in water resource management and has operated Aquatechnex since the mid 1970s. Aquatechnex is a service firm with expertise in lake management, restoring aquatic sites impacted by invasive aquatic weeds, and mitigating toxic algae blooms. Please welcome Terry McNabb.
Thanks. I appreciate the chance to talk to you a little bit today. So I was going to ask to talk a little bit about experiences managing Eurasian milfoil and flowering rush. So I'm going to kind of give a history of what we've been doing and some of the research work that's led to operational control. So this is a footprint of our company. We have 10 offices up and down the West Coast. Eurasian milfoil is a plant that we deal with from the Mexican border to the Canadian border. And a lot of the reservoirs above Los Angeles have had Eurasian milfoil for years. 2 years ago, we were able to do the first treatments on Lake Tahoe to focus on Eurasian milfoil. Flowering rush is a more recent thing we've worked on in the last decade or so, and it's primarily, in our neck of the woods, still up in the Columbia, Pondere River, Clark Fork neck of the woods. So in terms of aquatic herbicides, as Andrew said, we've got about 15 technologies, and I guess he's got a couple more on his list than I had on mine, but that in our toolbox. But a lot of times, one technology works well on one plant or one situation. You get limited by that a little bit, and so you're dealing with milfoils and things like that. Often the auxin herbicides are used because milfoil is unique in that there's two families of plants. There's the grass family and there's the broadleaf family. And most aquatic plants are in the grass family. Milfoil is in the broadleaf family. So if you have a herbicide specific to a broadleaf plant, you can theoretically selectively target it and remove an invasive species from a water body, and then let the natives kind of recover into that space. So 2,4-D is the first one that has been used for decades. Triclopyr is the next one, and then the Missoula was the more recent addition. So I'm going to kind of talk a little bit about some experience we've had that we've been lucky to have a relationship with. The U.S. Army Corps of Engineers owns more water than I think anybody on the planet, with all the dams and reservoirs, and they're charged by the federal government in early 1900s to develop methods to control aquatic weeds, because they were impacting water hyacinth was getting loose in the south. So the U.S. Army Corps of Engineers has a, world famous aquatic plant control research program, and since 1982 or so, we've been able to work under contract with them to do a lot of the development on herbicides and things. So I first worked for them in 1981 when they were brought out to map and come up with a plan to treat hyacinths in the Sacramento Delta. Worked a little bit on the river, but about 1988 or so, we started working really in close communication with the people who are working on herbicides. So this is kind of just their website. If you're interested in going there, there's tons of information. They've got a biocontrol program. They've got an aquatic herbicide technology program, which we primarily worked with. And then John Madsen, who you heard from this morning, worked for them for quite a while. So their whole theory has been, until about 1986, when sonar or fluoridone was registered, we had 2,4-D, we had diquat, and we had endothol. We had three basic tools you could use to manage aquatic plants. And most of those were contact. They got into the plant pretty quick. And, I think Andrew mentioned that fluoridone was patented in 1973, I think he said. It never got registered until 1986. It took them that long to get the information to EPA to get a label. But when it came out and was available, we were doing applications at max label rates, kind of like you would do with other three tools we had. And all across the country, people were finding that they're having really some stunning successes and some massive failures, and nobody understood why. And the researchers at the Corps, particularly Dr. Kurt Getzinger, started looking at, well, has anybody ever thought about contact exposure time? How long do these chemicals have to be around these plants in order to, for them to get a lethal dose and that type of thing? So they came up with a program where they look at these growth chambers in their laboratory, where they take and screen plants like milfoil, hydrilla, flowering rush. They screen them against all the different herbicides. They basically determine in a laboratory setting how long does this product have to be around this plant, and long enough, for it to receive a lethal dose and actually control itself. They'll find that in some cases, low rates work really well. There's other cases where you can see that you really have to, particular herbicide relates to get ramped up. The next thing they did was they took that to these mesocosm facilities they built. This one's in Louisville, Texas. In these mesocosms, they scaled up this thing. They put a bunch of different species in there, and they're looking more at selectivity. Can we selectively target milfoil with this herbicide and not impact other vegetation? Then what they hired us to do is to take that into the field. And in the late 1980s, the first thing they had us working on is these rhodamine dye applications, is what you see here. Rhodamine dye is a dye you can use to mimic a herbicide. You inject it into the lake. You can measure it with a fluorometer. So if you put it out at a known concentration, you can track, is this stuff staying here? Is it moving? How long is it around? That type of thing. Is it going downstream? And that's kind of the whole thought process behind how, they were looking at, and we were looking at making some of these technologies work better. So Eurasian milfoil, as you probably know, I'm not going to dwell on this slide too long, but it's one of the more prolific invasive aquatic weeds across the northern tier states. It impacts a number of beneficial uses that humans have. If you have a house on a lake, University of Michigan did a study. They figured that there's a 22% reduction in property values if your lake was full of Eurasian milfoil versus a lake that wasn't. But probably less well known is the impact on the environment. The Columbia River, for example, Eurasian milfoil has infested most of the side channel rearing habitat for salmon. As the young guys are going downstream, they can't go in these areas because the water is 20 degrees warmer than the water in the main channel. So you've got a situation where it needs to be controlled, and kind of these are the tools we've used in the past. So Floridone, John Madsen mentioned Long Lake this morning. That's a lake we treated in 1991, and after we had some of this contact exposure time, that was discovered in this core program that we had. It was more important to have very low amounts of Floridone around this plant for 6 to 8 weeks than it was to have a whole bunch of it there all at once. If Floridone ever dilutes out or moves away, or gets to the point where it's not, the plant's not exposed to it while still has any energy left, it would grow right out of it, and that's kind of what we were seeing. So Long Lake was probably the first major application we did, and we've had actual, John's graph started after 10, stopped after 10 years, I think. We've actually managed that lake every year since, including through today, and we found 2 or 3 plants Eurasian milfoil 1 year post-treatment. We haven't seen it since. So we've got the capability of this herbicide to eradicate Eurasian milfoil from a lake. The problem was, when it was a liquid, you basically had to dose the entire lake at 2 or 3 parts per billion, or at least the area above the thermocline, in order that the individual plants would get exposed. So it wasn't something you could use on a large scale, treating 100-acre lakes. Then they developed a number of slow release pellet technologies that let us kind of go after bigger bays and stuff. But this is just still a really cool technology to use along those lines. Triclopyr is kind of the next thing that came along, and it was registered about 2000. It kind of replaced 2,4-D as a selective systemic herbicide. It's got a pretty short contact exposure time, and in flowing water situations, the manufacturers have actually put it in a kind of a controlled release pellet. You can buy it as a liquid, or you can buy it as a controlled release pellet. So if you're worried about dilution and things like that, you can use it to kind of, like I said, selectively target Eurasian milfoil, and leave the natives behind, or let the natives recover into that space. The most recent one is Procelicor. This is one that was registered by the US EPA in 2018. It was registered under a new program that EPA has as a reduced risk herbicide, which means they're trying to register things that can replace technologies like 2,4-D that are older. It's got a drinking water tolerance. You can put it in drinking water without restricting the use of the water to deliver as a potable supply. It's got a very fast acting time. So we were aware of this technology through our work with the Corps a couple of years before it got registered, and this is just some of the stuff we were excited to kind of look at. But they did one study. I just want to this was done before the full registration came across, and we're pretty excited about it because of some of the hybrids we see up here. But in this particular case, this is one of these mesocosm studies, and this is a untreated plot 2 months post-treatment. You kind of see they've got the two species of milfoil in there. One of them is Eurasian, and one of them is the hybrid strain that's pretty resistant to 2,4-D that was identified in Hayden Lake, Idaho a bunch of years ago. And then they have 3 or 4 other species in their plants, pondweeds, Elodea, Vallisneria, things like that. If you look at the control area, this is a similar setup, 2 months post-treatment, 6 hours contact time, which is very short, and 3 parts per billion. The Eurasian milfoil and the natives were 100% controlled. And one of the more important things that that is I guess unique to this particular herbicide is it's got a very fast uptake time. You can get it in it doesn't want to be in the water. You put it in the water, it gets into the plants like lightning. So it's got a lot of applications in places like where you might flowing water situations, where you might not pick a herbicide like Floridone, for example, because it's not going to stay next to the plants long enough to do any good. So it's a real good tool for doing that type of work. So I'll just run through a couple examples and I'll switch over to flowering rush. These are, I didn't bring all these up just because of time, but this is, we're going to show American Lake in a few minutes later, and this is a picture of what the entire littoral zone of American Lake looked like. So when we get back to that in a minute, I'll talk about that. But the first experience we had with it operationally was registered in 2018. We did some work with ISDA and CPRO and the Army Corps people to get it in the water and kind of learn about it a little bit. So this is a bay off the Pend Oreille River downstream from Lake Pend Oreille. We set up a research plot, did a bunch of point intercept data across it to measure what species were present. We had a reference plot downstream. We came in and made the application. John Madsen at that point was still with USDA, and him and the Corps people basically came back at 6 weeks post-treatment, and there's no milfoil left alive in that plot. The native plants were thriving. They came back 1 year post-treatment, basically the same thing. So that's the kind of things we're seeing with that. American Lake is a 2,200 acre lake near Seattle, just south of Seattle. It's a glacial lake. It's pretty deep. It's got a kokanee fish in it. The entire shoreline out to the 20-foot contour was completely won over with Eurasian milfoil. So we built them an integrated aquatic vegetation management plan with a grant we got from our Department of Ecology. That program basically picked as Percellacor as the starting point for the treatment. We treated basically the entire littoral zone in 2019, and that's kind of what it looked like. It drops off pretty quick, so it's it's an area where you kind of expect to dilution and wave action might move the herbicide away from a plant if you picked one that needed to be around the plants longer. And then 1 year later, post-treatment, basically no milfoil. We've come back and we've been working on this lake every year since. We're finding a couple patches here and there around the boat ramps, and we're now targeting maybe 2 to 3 acres a year that have scattered plants in, but it's been something that's been pretty successful. The Clark Fork runs through, well, it's outside our door here, I guess. This is Noxon Reservoir on the upper end of the Clark Fork. We did a demonstration project for the Sanders County group back in 1919. This is a run-of-the-river reservoir where the water is moving through pretty quick. Did about a 30-acre plot up near the dam and a shoreline plot that was on kind of a more exposed area. This is kind of just a quick shot of the data. 6 weeks post-treatment, you can see the milfoil is pretty well hammered. And you can kind of see that it really hasn't had any impact on the native vegetation that's present there at all. And then the state of Montana came back and looked at all these points in there. 1 year post-treatment, they basically found no Eurasian milfoil in the big plot and a couple plants in the small shoreline plot. So Hayden Lake, Idaho, this is the lake that's famous for having a 2,4-D resistant strain of Eurasian milfoil. Similar project we did in 2019 with Percellacor. The state came in, state of ISDA, who we were working for, came back in 1 year post-treatment, did a point intercept grid across all 93 of those acres, and basically found no Eurasian milfoil present. So that's a tool, I think, that's got a lot of promise. So this is a dock I was standing on in 2005, and if I look down the river there was nothing there but Eurasian milfoil. And we did a treatment program for the state of Idaho and Bonner County in 2006, and did a real good job. And over time, funding kind of went away. But by 10 years later, standing on the same dock, and this is during drawdown, you can see that the milfoil is kind of still hanging around on the upper part, but the flowering rush is just running right down this river and running the milfoil out of the lake. And nobody really had much experience treating flowering rush probably until 10 or 12 years ago. It's just starting to be recognized as a problem. So again, the Corps of Engineers, in this case, the first trial we did was kind of a cooperative effort between CPRO and the Corps of Engineers. Andrew Scubo actually put this trial together and designed it. We used a combination of a couple of things on Lake Pend Oreille. This is a picture of the plot. Those little squares you see were areas where we came back and did point intercept pre and post treatment to measure plant species present. In this case, we put out granular application of triclopyr and then 2 applications of sonar or fluoridone at a couple week intervals to try to keep the concentration exposure time up. And the data that was collected on this, you can kind of see that 1 year post-treatment, we had pretty good results in terms of managing the flowering rush. There's still a little bit occurring at those points, but I'm going to show you a picture in a minute that tells a little bit different story. I think Andrew, that's about when you went to Savannah River, I think. Yeah. So nobody nobody followed up on this, but this particular picture. I'm going to come back and look at the reason we took this picture where we're flying was to look at this area, which I'm going to come to next. But if you look right in here, this is September, 2 years post-treatment of that plot that we did, and you can see visually that there's basically that was the monoculture topped out wall-to-wall flowering rush, and that 2 or 3 this is maybe almost 3 years post-treatment. It still looked very good, even though nobody was coming back to sample. So the next thing that we started working on in that particular area was in flowering rush was there's not a lot of chemistries that work on it well. Is there some we need to know more about treating it through the water column, but they're also at that point Bonner County was starting to look at, well, can we treat this? These lakes are drawn down a lot of times. The reservoirs drop 10 feet. They expose maybe the whole littoral area. So Bonner County Weed Department actually came out and was doing a couple of kind of just, can we go out here and make this, put a herbicide out, bare ground, and will it work? And they got the Corps guys organized, and we put another study together. This is the kind of the pre-treatment area of that slide I showed you a minute ago. So the water was drawn down. You can kind of see there's plots all staked out there. We had made an application right after bud break when the flowering rush was starting to sneak out of the soil in the kind of in the spring, and we used a couple different herbicides. We put out Mazapyr, we put out Mazamox, then we tank mixed Mazamox and 2,4-D and then triclopyr 2,4-D, and you can kind of see this shot was taken at the end of that summer. So the treatment was made in August, and these are just research plots. These are controls. This is these two are Mazamox or Clearcast, and these other two that look really clean are Mazapyr or Habitat. So that technology is something that we've operationalized where we can. There's a lot of benefits to doing that. You can kind of get out and getting out in the spring before stuff's up and growing. You can use a lot less herbicide because you're not trying to dose the volume of water. You can maybe use pints instead of gallons, and that from a cost perspective that gets to be a little bit. And then we're looking at drone technology more and more because sometimes the conditions you're trying to drive on the lake bottom get a little sketchy. So this kind of a bare ground herbicide trial summary. If you get a couple of years in a row, we found that we really get good long-lasting control. You get most of it the first year. You come back and do the plots the second year. You get really excellent control, and it doesn't cost a whole lot of money. So next thing we looked at was what can you do through the water column if you can't draw the thing down, and this is all flowering rush you're looking at here in a bay on Lake Pend Oreille. So we've done a lot of work with diquat, and that was also based a lot on what John Madsen did in Minnesota before he went to, you can't keep track where John Madsen worked when, but he worked for the University of Minnesota for a while, and that's a big problem there. So what he found was if you hit it with diquat 2 years in a row, you get really good results. So we came in with the Corps to kind of look at that. This is just one of the treatment plots. It was about 5 acres off the lake. You can kind of see this is the distribution of the plants inside that treatment plant. The one on the left is pre-treatment. The one on the right is post-treatment. It's a really good knockdown, excellent control. In all these trials, we found that, first year you get about, 80, you really good control, in 2 to 3 weeks or 4 weeks. You get a little bit of regrowth the next year. If you hit it again the second year, we found that, it's really thinned out to the point where it's not really even an issue. So summer trials, the one thing we did different this year, we added a herbicide to the mix. AquaStrike is a product that's manufactured by UPL. It's a combination of endothol and diquat. And the 6-week post-treatment data looked, a little bit better than the diquat. So we're kind of waiting to see this summer what's left of that plot and if it's a bit of a benefit or not. Last thing I'll talk about for a few minutes is years ago we were at a NALMS meeting, North American Lake Management Society, and we saw a company there that had bubble curtains, and they're using them as turbidity curtains around a dredge site. So inside this bubble curtain wall, they're doing some dredging, and there's all kind of suspended sediment. And outside the bubble curtain aerial photo, you can see there's absolutely nothing. So we were thinking, we've used turbidity curtains to isolate, treatment sites in the past. Is this something we can use in aquatics to kind of increase the contact exposure time in an area where flowing water is to make a herbicide work where it might not otherwise work? So you kind of see those lines there in the river. This is the first bay we treated the first year. There's 2 bubble curtains there. We did a dye study, and we basically treated it with dye with the bubble curtain off. We monitored how fast it went away, and we turned the bubble curtain on and duplicated it a day or 2 later, and we found we were able to increase the contact exposure time, and we doubled it. So a product like diquat worked pretty well in there. This one last slide is this is this is right in the main channel of the Columbia River, and it was just rocking and rolling through there. The bubble curtain didn't work quite as well as it did kind of cutting off an isolated side, but it does show you that this is a diquat and dye treatment that we've got. This is about a 5-acre plot. The outside edge of that is the bubble curtain. And so the one on the left, I think, is 1 hour post-treatment, and you can kind of see that the material's still hanging in there. The last one's 7 hours post-treatment. So something like diquat that gets into the plant pretty quick, it works. When we did this without the bubble curtain on, the dye was basically gone in 15 minutes. So it's just another tool that may or may not have some application. So flowering rush, what have we learned? I think we need to go back and look at the combination of triclopyr and soy and fluoridone. We've used triclopyr by itself, the one and only time we used it by itself, and we killed all the flowering rush, but it all floated. So it must have released from the sediment. So we haven't gone back to do that. But if you look at those plots that Andrew started years ago, we got 2 to 3 years of control with one of those 2 things. We probably need to look at that. I think we've got contact herbicides that work through the water as long as you understand the contact exposure time, and it might take a year or 2 to do it. I think the drawdown applications, if you can do that, make a lot of sense, because you can prevent the thing from ever coming up in the first place. You can control large areas with a lot less money. The chemical cost alone can be maybe a third or less of what you do if you're trying to treat it through the water column. So those are kind of, I think, where things are. If anybody wants to copy of this, I guess you're filming it, so maybe I don't need to say that, but we make it available, and it's time for lunch. So if anybody has me on your form, your bingo card, the line form's here. So thanks.
A few minutes for questions. If anybody has any questions for Terry, just ask.
Were you involved in the dog leg treatment in Yakima County several years ago?
Yes. One of my guys were running.
What was the question?
Well, she wanted to know if we were doing, there's a treatment in Yakima County a couple of years ago. As a matter of fact, we forgot to turn your permit off, so we can bill for it every year.
Which we addressed that last spring. I'm hoping it actually went on. That was a really cool pulling and vacuum process.
Yeah. Yeah. It's a neat lake.
We haven't seen it come back. That's it.
Anybody else? Thanks.
Nope,
Oh, sorry.
If I'm interested in maybe some more information on a particular study, is that something I could possibly get some info on?
So the Corps has published most of this stuff.
Okay.
So their job is to research and publish and make this information available. So a lot of the stuff that we just did in the last year or two is still in either maybe review or whatever, but a lot of it's loose. And then Carlton, who's standing next to you with the Aquatic Ecosystem Restoration Fund, they've funded a lot of this work, and they've published a lot of it too. They've got, I think, a few white papers and things that you can look at. So.
Any other questions? All right, well, thank you so much, Terry.
Thanks.